Okay, voice test 111. Just post there. Okay, voice test 111. Just post there. Okay, so I think we should be live now. It's going to the advent of God. Okay, 56 seconds. Today we're gonna be using TypeScript with ban. Yeah, we're gonna use ban and TypeScript. Yep. Let's wait for it to open up. Today's challenge. Let me open up my water. 30 seconds. Okay, የዛሬን ስንጨርስ አራት ቻሌንጆች ነው የሚቀረን ቀጣይ. So we should be done by Friday, I think. Is Friday gonna be the last day or maybe? I think Friday. የመጨረሻ ቀን ነው የሚሆነው. 5, 4, 3, 2, 1, go. Okay. Let's open up day 8. Okay, day 8 playground. Equipped with a new understanding of the teleporter maintenance, you confidently step onto the repair teleporter pod. You rematerialize on an unfamiliar teleporter pod and find yourself in a vast underground space which contains a giant playground. Across the playground, a group of elves are working on setting up an ambitious Christmas decoration project. Through carefully rigging, they have suspended a large number of small electrical junction boxes. Their plan is to connect the junction boxes with long strings of lights. Most of the junction boxes don't provide electricity. However, when two junction boxes are connected by a string of lights, electricity can pass between those two junction boxes. The elves are trying to figure out which junction boxes to connect so that electricity can reach every junction box. They have a list of all their junction boxes positions in 3D space. Okay, this is okay. For example, this list describes the position of 20 junction boxes, one per line. Each position is given as XYZ coordinates. So the first junction box in the list is blah blah blah. To save on string lights, the elf would like to focus on connecting pairs of junction boxes that are close together as possible. Okay, according to the straight line distance, in this example, the two junction boxes which are closest together are, by connecting these two junction boxes together because electricity can flow between them, they become part of the same circuit. After connecting them, there is a single circuit which contains two junction boxes, and the remaining 18 junction boxes remain in their own individual circuits. Now the two junction boxes which are closest together aren't already connected, directly connected, are okay. After connecting them, since is already connected to another one, because okay, yeah, to another junction box, there is now a single circuit which contains 3 junction boxes and an additional 17 circuits which contain 1 junction box each. The next 2 junction boxes to connect are after connecting them, there is a circuit containing, okay. The next 2 junction boxes are, because those 2 junctions were already in the same circuit, nothing happens. Okay, this process continues for a while, and the elves are concerned that they don't have enough extension cables for all these circuits. They would like to know how big the circuit will be. After making the 10 shortest connections, there are 11 circuits. One circuit which contains 5 junction boxes one circuit which contains 4 junction boxes, two circuits which contain two junction boxes each, and 7 circuits which each contain a single junction box multiplying together the sizes of the 3 largest circuits, 5, 4, and 1. The circuits of 40 usually contain many junction boxes. After together the connect together the 1000 pairs of junction boxes which are closest together. Afterwards, what do you get if you multiply together the size of the 3 largest circuits? How long is our input? Very long. Okay. I don't really understand. I think it's gonna be, we're gonna loop over, and based on the distance keep combining them. It's like a fold kind of thing. So we have day 8 right here, part 1, and then inputs example.txt. Let's paste it in here. Okay, let's open up our file, and then let's open up our runner here, ban source index.ts. Of course we don't have it, we're not logging anything. Console log, let's log the inputs so that we can see something. I think we need to trim this thing. Let's do trim. Okay. X, Y, Z positions, a straight line distance. So it's like Pythagoras theorem, or Euclidean distance. Yeah, so here 1 point minus, okay. So we get the distance between each one of them. The list describes the position of 20 junction boxes, one per line. Each position is given to save, okay, blah, 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 blah. According to the straight line, in this example, the two junction boxes which are closest together are this and this. So this 162 and 425. So we have to know like we have to do like a distance for each one of them, for each, like it's gonna be an n square loop for each one. It's gonna be an n square loop. So let's go into our input, start parsing for of this here. Should we parse this out into a, okay, so let's do const positions will be input dot lines, not top lines, input dot split on a new line, and then map over each one x, and then just split it on that, and then split it on comma call parse int. Okay, and then map x parse int x. Okay, and then we say for const x, y, z of positions, we're gonna compare it against all the other ones. Now the two junction boxes are which are the closest together but aren't already connected are that after connecting them, since is already connected to another junction, there is now a single circuit which contains three junction boxes. I don't really get it. Do we have to create a graph? Is this a graph problem? I think it might be a graph problem. Holy shit, no. Are we just gonna loop over them and then find um, keep finding the shortest one? So we're gonna have to do something like this. Is it something like it's a double loop for each one, and then we do connect distance will be, let's call this x1, x2, y2, y2, y1, and then z1, and then let's call it z2, and then to do x2 minus x1 square. I guess we need to square them. y2 minus y1 plus z2 minus z1 z1. And it's all of them are squared, so I need to do maths dot power. Actually, I don't think we need to do this. If we do, let's do, does Ben have a ripple? I don't think Ben has a ripple, but let's do node. If I do, I think power 2, yeah, that's supported, so just need to do the power of 2, and then to the power of 2. It's going to take config. No property access from indexes. That's what it's complaining about. Space start. Can just do this to all of them, I guess. Exclamation. And then, so that's the distance squared. And then we can do, I guess, can do mods square root on all of them. And then we're gonna have to start with the mean. That's gonna start at infinity. And if distance is less than mean, we set mean to distance. Or I guess in this case let's do mean pose will be null, but when we find one we do mean pose equals x2, y2, z2. That's what it's saying, it's asking us to do. And then once we're finished with the inner loop, let's log the mean pose. Yeah, okay, so I guess let's do mean pose, and the pose is for x1, y1, and z1. Okay, I guess for all of them it's gonna be themselves. Okay, we gotta filter them out. So if x1 equals, or I guess if we can do x1 comma x2 comma no, y1 comma z1 equals x2 y2 z2, then continue. Okay, I guess the condition. Okay, and then I guess we can do this then. X2 and y1 equals y2 and z1 equals z2. If that's the case, just let's go back here. Okay, the closest one for that was 4 to 5. Okay, so it's saying how many times should we do this? By connecting these two junction boxes together, because electricity can flow between them, they become part of the same circuit. They become part of the same circuit. After connecting them, there is a single circuit which contains two junction boxes. I think this is sounding like a graph problem, and I literally have no clue about graph algorithms. After connecting them, there is a single circuit which contains two junction boxes, and the remaining 18 junction boxes will remain in their own individual circuits. Okay, so we're not gonna do this for the other ones. So I think this is gonna be a loop. So they said do this process 10 times here, and then in here they said do it 1000 times. So I don't think we should be looping over the whole positions list, but loop over I guess the times they've told us to loop over. But then what should we be doing? Now the two junction boxes which are closest together but aren't already directly connected are 162 and 431. So we connected 163 and then so we connected 162 and 425. Where is 425? So this 425. So we connected these two because they are just the two closest ones from each other to each other. And then in the next loop, we modify. So this will be like a map of positions to two slices. So in that case, when we connect something, we remove it from the map and then we add it to the lists of the positions that are connected to the one number. So now that the two junction boxes which are closest together but aren't already directly connected, now that the two junction boxes, how did we get to two junction boxes? Wait a minute. So we have in this example, we have one circuit with two junction boxes. By connecting these two boxes together, because electricity, so we created a circuit, which means in our case that array now has two values in it instead of one, because electricity can flow between them. They become part of the same circuit after connecting them. Okay, in that case, there is a single circuit which contains, and the remaining 18 junction boxes remain in their own individual circuits. Now the two junction boxes which are closest together but aren't already connected are, so now since it's part of 162, we're not checking anything with 4 to 5 anymore. So it's like we're now checking with this number, because that's the parent of the circuit. And then when we go over the loop again, now it's closer to 431. And okay, I think I'm understanding this now. I think I understand now. So what we need to do is create a map here. Cool. So let's do this. So this is gonna be our map. Let's call it the map panel, and then it's gonna be a map of. We can use an object here, but should we use an object? It will make our lives easier, I think. I don't think so. let's use a map. I'm not sure though. How would a map help us more? I don't think a map will help us more. But so it's gonna be x1 comma no I mean number comma number comma number 2. So that's the first, that's the key of our map, and then the value is gonna be number comma number comma number list, right? So when we start off, this is gonna be the initial state of the map. So since each one of them, each junction box is a circuit by itself, so we're gonna insert map dot, how do you add stuff to this? Clear set, yeah, set map dot set. So x1 no, we don't need to index this x. So we can, this is gonna be, I guess this is gonna be, I know a good name for circuits. So these are the circuits, and we're inserting the junction boxes into it to initialize it. And then this is something like I think we probably could have done array from this, but let's do this manually, insert them. So x, y, z. So when we start off, it's kind of like all of them are in their own separate circuits. Each junction box is a single circuit, right? And then what we're going to do here is we're gonna say while a step is less than 10, and then let's say step equals 0, and then I guess I'm doing a for loop. Why am I writing a for loop like this? Let's just forget about it. Step, okay, and then increment that, and then in here we're gonna need to map over the circuits, map over each circuit, and then create a list, or let's do this late mean distance it's gonna be infinity, and let's say let mean junction equals null, and then we're basically gonna do the same loop we had earlier, but now it's gonna map over the circuits instead. So now we're gonna have to do circuits dot entries, right? And this will be something like this. So we'll do this, and it needs to be a double loop, and then this is 1 1 1, and then 2 2 1, no 2 2 2 and then we need to calculate the distance. Why did I delete the old code? So let's do this. It's gonna be mod dot square root, and then it's gonna be x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2, and plus z2 minus z1 to the power of 2. And then if distance, I guess let's call this distance, if distance is less than the minimum distance, then the new distance is gonna be mean distance, and oh no, the mean distance is gonna be distance, and then so our new mean junction will be x1 comma x2 and then comma z1. I don't know if are we just gonna be matching over the string, are we gonna just matching over the start position, or should we be considering the other values in the array? The next two junction boxes are okay. So connecting since all already connected. Now a single circuit which contains okay. The next two junction boxes to connect are 906. After connecting them, there is a circuit. I don't think we should be. I don't think maybe we have to. We're not looking at the values here. So I think maybe we need to look at all the distance between the values. So I don't think it's gonna be like after we connected them, we really need to check the distance for all other ones with the first one only. Maybe I'm not sure. Let's try this out, and if it fails, we'll try something. So this is done, I think. So after we're done, after we found the at least from all of them, right? The ones that are closest together are, let's do one, and then in this case I think so. So I guess mean junction is gonna be something like this. We're gonna need to know both of the numbers. The smallest distance between all of them, not x1, y1, and z1, comma x2, y2, and then z2. Let's not mess up. x2 minus y1, y2 minus y1, z2 minus y1. Okay, so I think this is actually what's supposed to be. So and then let's log mean junction. Here we should be see I think so 162 and then 425 blah blah blah. Oh, and then we forgot that check if x1 equals x2 and y1 equals y2 and z1 equals z2, continue. Okay, so once we have this, this is what we're going to do. So let's destructure it, right? Let's do x1, x2, y1, z1. Paste that here, and then let's do this, and then last mean junction, right? We can does it not know the type? I don't think it does. It's gonna be number and number followed by number. So what it's saying is we need to join these two, the circuits that are created by these two positions into a single thing. And then we need to remove the second one from the list because now we shouldn't be keeping track of it. Is that what I'm hearing? I don't think so. Let's try that out. But So what we should be doing here is entries, no, what we call them, circuits dot get with x1 comma x2 comma x3. No, what am I doing? x1 comma y1 comma z1. Can we just directly push to it because it's a list? So we want to push this value here, x2, y2, and then z2, but then we have to remove that from the circuits list. Circuits dot delete x1 comma x2 comma y2 comma z2. I think this is how we should do it. And then in the next loop it will do its thing. So at the end of it, let's log the circuits to see what they look like, and let's run this 2 times now. So according to this, what we should be seeing is 162 will now connect to 431 as well. So we should see the map value of this at this index have 461, 431, and then 425 as well. So it will have 2 elements. Now the two junctions are connected better. Yeah, so let's make this less than 2, and then let's see how this goes. Okay. So in the final log, wait a minute, all of them just have. Is this not working? Is the pushing not working? Do I have to update that list manually myself? Say if let's look at this. Let's look at output. So 162, this got connected to these values. This one didn't get connected at all. So this one got connected. This one got connected. Okay, after making the 10 shortest connections, there are 11 circuits. One circuit which contains 5 junction boxes, one circuit which contains 4 junction boxes, 2 circuits which contain 2. We don't have 2 that contain 4. We only have 1 that contains 4. A single junction box. Okay, I think so. It does need to look at the other ones as well. So here we should be also comparing them with the distance of the values, and so we're gonna be iterating over a list of circuits. At first, each junction will be considered as a separate circuit by itself, and then every single time we loop over, we check and then what we need to remove is this deleting business, I think. Yeah, but how do we if we don't delete it? So let's look at what it will be messed up. What if we save dot? Yeah, so if we don't delete it, we will never end up grouping stuff, or all of them will be grouped into one. but we'll have a lot of duplicates. It will just loop over 10 times adding stuff to this, because it will always find this one. So instead of, we don't have to look for, I think we should be doing is filtering out. So just like we're ignoring ourselves, we have to ignore, if it's already in there, we have to ignore it, right? So for the current key, for the current keys values, or for, I think this one, I don't see us using this, but, or maybe we are going to be using this. What I'm trying to say is, if values dot map, and I'm just going to generate a string x dot join, right, with columns, let's just do this, if values dot map x dot join, includes, I guess, includes key 2, then continue. If the current map we're looking at already contains, so let's say we're comparing against 161, and then 42 will be, so yeah, I think it will eliminate the need for the deleting we're doing. This seems correct, but I think we need to deduplicate it. So they said there is one which contains 5, but I don't see one that contains 5. There is this contains 2 values. It contains, there's one that contains, but it's the same one. It's 4 to 5. It's, and then 4, 3, 1, the same thing. Now we're comparing each one against the other, and then we're building the circuit from every direction. Let's run this let's run this 20 times. But finally they will end up, all of them will end up like in one list, right? That's the final ending condition. Let's say if we run this for 100 times, it's just duplicates. There are a whole bunch of duplicates, right? Am I saying duplicates? And there's 739 is a duplicate. 592 970 941 352. Let's run this 10 times, but the 10 shortest connections. Let's ignore this and let's look at the connections we've created. So console log connection, and it's between, let's I guess it is just min junction, right? And then just map over them and let's join them with a colon to have it. So first we created a connection between 162 and 425, which is according to this correct 162, and in this example that we also which are close together one. Okay, that's correct. And then in the next one it's between 162. Now the two junction boxes which are the closest together but aren't already directly connected are 162 and 431, but in our case they ended up being 425 and 461 162. Okay, that needs to be ignored. Needs to be ignored. That's making us lose a step. We're trying to connect an existing connection again. So okay, so how we can solve that by here. We add both of them to each other's list. So y2 and then add x1. In that case, I think hopefully it will be filtered out. So the first step 162 and then 425, and in the second step it's 162 and 431, and then the third 906. Did I say 906? The next two which are 906 and 805 after connecting them. Okay, that's correct, 906 and 805. And then did I say, and then the next two 431 and 425. 431 and 425, that's correct. Okay, I think we have it now. So let's go in here, let's log the circuits, let's comment out that. Okay, now let's count this. We have how many? After making the 10 shortest connections, there are 11 circuits. One circuit which contains 5 junction boxes. Is there one that contains 5? 1, 2, 3, 4. I don't see any that contain 5. 1, 2, 3, 4. Come on. 2, 3, 4. Okay, let's see. And then there are 11 circuits. There are 20 circuits, but these haven't been deduplicated. We're just keeping track of, so we can count those, right? We can outside of this we can say 4. We can create a let's do a string. Let's do circuits. Let's call, I guess, final. Let's call it armor, and then circuits dot entries dot map dot, I guess, dot entries. And can we do a dot map? Yes, we can. And we don't care about the key, we only care about the values. But give me the values. No, the values dot map again. Where is this? How do you pass in the? Oh, it's gonna be something like that. Okay, something like this. Values for each one, x dot join with a colon or with a comma, and then I guess new set from this, and then console log final. I don't know why this is complaining. Is it because we haven't specified the type? The heck is this? So they expect me to do stuff like this? No, it's x, and then let's do x colon 1. Okay, these are the final values, but this is wrong, this is wrong, this is wrong. This is 431. When a connection is made, all of the values of the last one will be part of the new one. So let's say a circuit got connected to 162. That doesn't mean that they just got connected to 162. They got connected to all the nodes of 162. So here what we should be doing here instead is so let's say this will be const values 1. They're not just connecting to the single node, they're connecting to the, and then this is values 2. What? Hello everyone, am I still live? It's saying chat got disconnected here. Hello, can you see this? I'm using TypeScript, by the way. Am I still online? I don't know. Why did it say chat got disconnected? Maybe I was offline there for a moment. Hello. Am I online? Can somebody confirm? I think I am online. But what I was doing is, yeah, so it's not just, it doesn't just get connected to that single node. It connects to the whole group, right? So we should be doing is values dot one dot push values 2, but we're only doing this at the moment it connects to the other node. We're not I think this is still wrong. Not push, but it's a push and then I guess spread them in. I don't think this will still work because once it continues, what if that other node, after getting connected to some other node, kept evolving? I think I'm not using the correct data structure to store the console, the circuits. Yeah, I'm not using the correct data structure, or I'm not using the correct key. Ban source. Yeah, now we have way too much stuff. But of course they are not deduplicated and they contain duplicates. So that's why we need to do this final deduplication step. So let's see, what does this help us to do? I don't think it helps us to duplicate much. I don't think, yeah, it doesn't help us that much, but it does print them out nicely. So let's go back. Actually, let's go back. The connections are correct. I'm sure that the connections we're making. So let's take connections. Bam. So 162 connects to 425, 162 connects to 431, 906 connects to 805, and then 425 connects to 431. All of these are like all of the steps they told us to make. This process goes on for a while, so it's 826 connects to this, 521 connects to 117, 819 connects to this, connects to this, connects to that. But every single time, like these connections, when every single, no, everything, when every time these connections are happening, we need to have another data structure that we are updating. Right, so if we get told that 162 got connected to 425, then we should create a node called 162 and add 425 to it. And when we got told 162 got connected, and then we can do that again. And then next time when we get told 425 got connected to something else, that means 162 also got connected to it. Right, so for example here 425 got connected to 431, but that doesn't make that shouldn't make any updates to the map, to that data structure I'm talking about. But here, for example, when 346 gets connected to 425, it means it also got connected into 162, or it should be in that array. So what we should be doing is, I guess, it's gonna be a map, but what should the map be keyed by? The indexing function will be something like if the key is the same thing I'm giving you as, or if that key is contained within the values. What is that data structure? What's that data structure? I don't know. We've already been here for 1 hour. Okay. Come on, let's do this. Come on. Okay, I think this is probably part 2 is gonna be way harder than this, I think, but I think this is relatively simple. So we were deleting keys earlier, but that wasn't giving us the correct connections. So let's keep the connection log there. We are deleting keys, but it's not doing it. We know that these things are correct. We just need to create some data structure here. Let's call this. Let's just have an object. Let's not have an object, so that object is something like this. What we're gonna do is if object, after doing all of the processing to make our thing work, we're gonna update the final circuit object. If, let's say, so what we're gonna do is get the object at, I guess, value equals the object at this key right. If there is something there, if we have a value, the push x2 comma y2 comma z2, but not that, but not like that, but this is like, how do you like I guess let's say map representation. Yes. No, I mean a graph. Add vertex, add age, and then adjacency list. And maybe this is what we need to do, because each one of them is gonna be a node, and then add vertex A, add vertex B, add age between A and B. So what is it doing? Add age will look and then add them to the list of 4 pose. Yeah, I need something like that. So this is like an object to list. So this is the actual circuit. So let's remove this map bullshit. Circuits should be this, and then circuits add. So add age is just gonna be initializing this. So at this key we have, should we start with an empty, or I think we shouldn't start with an empty list, we should start with ourselves. And this is a record of string to numbers. And then if, so okay, so for of, now I guess this is gotta be a for in loop. I don't know how to do a for. I forgot for in. It's just for okay. It's just like this, but instead it's in circuits, right? For, and then you can't destructure it. I think it's just keys, so it's just a key for key 1 in circuits. And then for key 2 of circuits, okay. And then if the keys are the same, we ignore it. But if we should also ignore it if it's already connected, which is values is equals to circuits at dot key do that. So if values contains, if values dot map includes, I guess we can do this here because that's, we're always gonna do so val dot join with a colon, and here we can say if values includes, if it's already in there, if these 2 vertices have already been connected, ignore them. If these two, yeah, if 2 vertices have already been connected, ignore them. So if not, we have like, and then so finally we'll have the minimum junction, the minimum connection after connecting, or after considering all of the vertices. We have the 2 points that should be connected to each other. And then what we should do is we're gonna say, so how did they implement add age between A and B? So we're gonna do not this, but circuits at this key 1 or key 1. Circuits at key 1 push x2 y2 and z2, and then this is for key 1 and then for key 2 it's the same thing, but this is on 2s, and then we can do this, and then it's gonna be adding 1. This seems correct to me. Let's see that we're getting the same connections, or if we're getting two new connections. So this list is correct, or I guess the order of the things got changed. And then let's see this final thing we've created, circuits. It's still not correct. How do we have 5 in there? How do we have 5 edges in there? This is the same as this, but this one has 1, 2, 3, 4. Also including this, right? Including this, it has 1, 2, 3. And then are we seeing any duplicates? No, there are no duplicates, so this is working correctly. But how many times are we wrong about how many times that it needs to be run? There are 11 circuits. Let's say so let's say const circuits is gonna be something like circuits dot object, I guess, object dot values circuits, and then map over each list. So this will be a list, I think. If we do that and see, yeah, it's gonna be a list, and then we need to map over those and join them up together to be like this. Let me check my phone. I guess I say unique, and let's print out unique. And then if we add a new set, if we create a new set from this, will they be deduplicated? But this adjacency list stuff he created is it's not correct. Adjacency lists values. I guess in an adjacency list, you in order to list the values, you have to go look at each node and then flatten out those values. But and then I guess the unique thing is not working, even though we've created them, we've made them be a list of. I think it's not working. We have 1 with 4, we have 2 with 3, and then but we were supposed to have 1 with 5, 1 with 4. I think these two can be merged in. I don't know why they're not being merged in, but these two can be merged in. Let's give it one more step. No, it won't do it. It won't do it. It won't do it. It won't do it. Maybe we also need to do this key, val or join. Something like this. We also need to we need to add it to the current key, but then we have to also update all the positions of the current key to also include. And then I guess after we have to add those, and then we have to also add it to this, and then also the same kind of thing should be happening there. So it's gonna be const values, and then we have to do a loop, and then we can say that it's gonna be once instead. It's gonna be 1 1 1. for each of the values, we also need to tell them that a new node has been added to the current circuit. I think I'm correct about this maybe, but I don't know. It will create a bunch of noise to see this, but let's see. Whoa, that's way too much stuff. Okay, if it doesn't contain them, or if it doesn't contain them, we need to add them. So let's say const values equals this. We can say something like contains circuit dot val. I guess no values. Let's say here we know it's gonna be their values. The map and includes val dot. What are we trying to add? Oh no, key one. If not contains, then values something like this. Here it will be this. And then boop. We can do this. And then if it doesn't contain it, add it to the list. One, two, three, four. 1, 2, 3, 4. 1, 2, 3, 4, 5. I think we just figured it out. Maybe 1, 2, 3, 4, 5, 6, 7. That's wrong. That's completely wrong. But there are duplicates. How did we end up with duplicates? Oh, because we're checking with the wrong. We're checking if it contains the wrong value. So let's do that again. So 1, 2, 3, 1, 2, 3, 4. But we don't have any 5s. Which connection are we missing? I don't know which connection we are missing. One, two, three, four. 1, 2, 3. Do this. See, it bugs in this. We are trying to join different nodes together. I don't see why this will work. We're joining over each other's children. So when we get told like 161 connects to 425, we add all of the numbers of 161 to 4 to 5, and we do the same to the other one, and then we keep evolving that for the other ones as well, because we're seeing the value. So even if it gets added after like some time after the node so after a node has like an edge has been created, if the other node connects to another node, we'll be going over each of its values and join them together. So wrong duplicate check. You are adding x2 but checking for key 1. Ah, ah. Wait a minute. Okay, the values 1 is gonna be key 1. We're going to be adding key 2 to it, and then we're gonna be adding key 1 to this. Okay, 1 2 3 4 5 6 7. What? When adding x2 it should be like that. When adding x1 to everyone circuit, it should be like that. Okay, 1 2 3 4 5. 1 2 3 4. 1 2 3 4. 1 2 3 4. Yeah, we need to do some deduplication because these two, for example, are exactly the same. So if you can't do stuff like this in JavaScript, what an annoying thing. But you can't do, like, you can't say, like, let's take two numbers that are the same. You can't say stuff like equals and then, no, arrays, I mean. If these two arrays are, yeah, it's gonna be false. It's gonna be false. You have to do something like maybe join them together, I guess. Join them. Yeah, that's how you get through. But for some of the duplicates, their order might be incorrect, right? So no, their order might be reversed, or for example, is this a duplicate? I don't really know. How do we dedupe this? We can sort them. Maybe we can sort the values inside. by their sum. I don't know how would you sort this. We can convert each one of them and then sort them and then dedupe them again. So let's say groups equals circuits dot circuits dot map. So sorry, no, object of values, object dot values. And then so for each circuit we're gonna map over them, and then for each node we're gonna end dot join them together. But then before we close up, we're gonna sort them, or I guess two sorted. I guess sort. Yep. We're gonna sort them together and see. Let's see the groups. Of course, let's do and then sort two sorted, and then let's sort them by length actually. X, Y, and then x dot length minus y dot length. Let's see if we're going down the correct direction. Console.log groups. But this is a completely incorrect, right? How is this getting printed? How that's a crazy way to print stuff. I guess we're gonna have to do this then to make it be readable. Const group of groups console log group. Okay, I think this is correct now. We have 1 with 5. We have 4 with 4. One circuit which contains 4. We have one circuit which contains 5 junction boxes, one circuit which contains 4 junction boxes. Okay, we have one that contains 5, and then we have these are duplicates, but let's run the duplication on them. How do we do that? So let's do that. So once they're all sorted together, let's join them again. No, let's join the inner ones. So let's join the circuits together. After sorting them, let's do bun format. Save and then I guess. After sorting them, let's join them together with pipe, and let's see what that looks like. Okay, and then let's add this to let's create this into let's add this into a set. Let's create a new set from this. Let's console log the console log group, which is now a set. This set contains 15 elements. It should contain only 11 elements. So if there are two that start with the same ones, we'll take the longer ones. um, I think that's the problem here. Since we're connecting each one, we don't know the longest one. So so for how do we do that? If they maybe after sorting them we need to, and then joining them to this, or sorting them, after sorting them we can check, because without joining them we can see even without joining them we were able to see that the first ones were the same. So we can say a fold kind of thing. These two are the same. The only thing that's kind of complicating it is because 805 got added in between, but the two other nodes are there. Just because 805 got added there, it complicated our deduplication logic. I think we need to maybe do this. So for group of groups, let's say if and then it's, I guess we need to call to array or values, and then to array group const we're gonna say, I guess, const final equals groups dot filter, maybe filter group where const length no, okay, so let's say where, so we're gonna filter all the ones, maybe no, also all so let's say group start equals group dot split with the pipe at index 0, and then if there are all others equals all others groups dot any I guess like it's sum. If groups dot sum, there are some that, or I guess let's do groups dot filter x, where x starts with the group, the same group start. So these are all the others that start with the same group stars. So okay, so exists with, okay, let's say longer exists is gonna be, this is a stupid way to do this, but all others dot sum x, where x dot length, x dot split with, I guess, just 2x dot length is greater than group dot length. So if longer exists, then false. Otherwise, this function return false. Otherwise, it will. I guess this is gonna be return not longer exists. Return then console log. So now we can, now let's say final map, and this one is going to be a record of numbers to, I guess, numbers to string like this. And then we're gonna, for line and final, we're gonna say I guess nodes are equals to oh, I thought it would be, I guess in this case it will just push the line then, and then this will be then wait, I guess, just to cut the final map. We need to create that it doesn't exist. Okay, so they're saying there are 11 circuits. One circuit which contains 5 boxes. This is it. One which contains 4, 2 that contain 2, one which contains 4, and then 2 that contain 2, no, one that contains 3. Ah, come on. There is none that contains 3. Maybe because this is part of another one. Is this sequence part of another one? Where is, let's say 9, 8, 4. 984 is like twice. That's what's confusing it. So just selecting and filtering out by the first is not gonna work. What about 862? Okay, let's see. 862. 862 is only in there one. So 862 is maybe one of the nodes that don't make any connections, hopefully. Okay, but there are 3 that contain 2 in our case, but there are only supposed to be 2 that contain 2, and 7 circuits which each contain a single one. Let's say 1, 2, 3, 4, 5, 6, 7. So there is some issue happening here, but 3, 4, 6 is definitely part of something else. I've seen that before here. So let's go back up here before doing this all like filtering and other bullshit. Const groups, or let's say const, please look at it. Where is this? No, it's circuits, not groups. So what we should be doing for each one, well, we're gonna need to iterate over each position again, and then find the largest map from all the lists that contains that node, but the longest one. And then after we found the longest one, how can we I guess we can delete the other one, straight up delete it from the object, right? I think that could work. Let's say this filtering logic is too complex and it's not gonna work. So what we should be doing instead is for const, so just delete the longest one, you have to delete the shortest one. Of positions. Wow, it's like time goes really fast when I'm doing Advent, of course. We're nearing up for 2 hours. Yeah. Okay, okay, so we're gonna look at all the values. So let's say values object, or let's say all circuits object of values, and then that's circuits. And then what we're trying to do now is to deduplicate it. And then how do we do that is by checking if all circuits let's say and then contained in let's do this actually to help us compare them. Let's do key is gonna be host.join key contained in, so all circuits.filter the circuits which circuit dot map x dot join colon includes key. Actually, instead of being like this, it should be, so we found it, so how do we delete it? So we should be able to know which node it was in. And this, if it's not the longest, just delete it. Let's say this find, or no, let's say that, and then the one with the maximum. So, and then we're gonna say we've mapped the circuit and joined them, and then we're gonna check, and then we're gonna map over each one, map over each circuit. I guess not map over, but let's say to sorted, but the comparison function is A plus comma B. Both of them are lists, so we're gonna say A dot length minus B dot length, and then at minus 1. So it is logging the longest one, 2, 3, 4, 5. It is logging the longest one. So, and then what we are going to want is so what we're gonna want is something like this contained in, but it's gonna be object dot entries. Right, and then this will be thing like circuit underscore, and then when even when we're sorting them, it should be underscore comma, and then underscore comma B. So they are contained within these. So map yeah, we'll delete the last one because that's the node we want to keep, and then we will say for const node in contained in, we will delete circuits at that node, and then maybe finally log the log what's left. Well, that's still way too big. Nothing got deleted, I think. Deleting and then node. Oh. Wait a minute. What does object dynamic trace return? Returns an array of key values, and then we off. Okay, now that simplified it, and then let's see. Now that seems correct. Let's see object dot values dot links 11. Nice. Okay, now let's do the count again. So you're telling me there are 11 circuits. Which one circuit? Okay, 5, 1 which contains 5. Let's say 1, 2, 3, 4, 5. 1 which contains 4. 1, 2, 3, 4. 1 circuit which contains 2 circuits that contain 2. 1, 2, 1, 2, and then 7 circuits. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so we're gonna now. So what does it say? Multiplying together the sizes of the 3 largest circuits, 5, 4, and 1. Okay, so let's say finally we're gonna be able to invert the grouping by, I think we can just do, let's do console log. How can we group them? We're gonna say console no, for, let's say group as an object. It's gonna be a record. Let's say we'll figure it out as we go along. So it's gonna be, but first we're gonna call const circuit of object dot values circuits, and then it's gonna be the same thing we had here. It's gonna take it out of the group with its circuit dot length, right? It will be number to number, I guess. So group then we can say if count exists. If count exists, we're gonna say group. If it doesn't exist, we're gonna say 1. If it does exist, it's gonna be count plus 1. And then what does it say? Okay, we're gonna iterate over the keys. So let's say multiplying together the sizes of the 3 largest circuits. 4 times 2, it's gonna produce 40. Okay, it's the object dot keys. Okay, let's hope this works for the actual inputs. We're still on part 1. It's crazy. Let's remove this, but yep, let's go up there, and I guess let's quit out of this, and then let's do save to not to desktop to workspace, and then move. Oh, not a number. No, so it hints false. It does work for the example, right? Though maybe we hard coded some stuff for specifically for the example. Okay. Oh, they said the step have to be 1000, right? They said you connect together the 1000 pairs of junction boxes which are closest together. Oh, your list contains many junction boxes. Connect together 1000 pairs of junction boxes which are closest together after one. Yeah, the 1000 pairs. So we're gonna need to create 1000 connections. That's why maybe it failed. In the example we only had to do 10. Oh no, this is it. It's gonna back out like as we ኮን እየሰራን ወደ መጨረሻው ቀን እየቀረብን ስንመጣ all of them are gonna end up looking like this, like doing giant like loops, because here we're doing like two loops inside of each other. It's horrible. Nested loops and stuff. This is horrible. And then if we're getting stuck like this on part 1, part 2 is gonna destroy us. We're doing so many loops. There's a loop here, there's a loop inside of it, and then I think we need this double loop. I don't see how we can do it without the double loop. Maybe if we sort the nodes by their distance to each other, or memorize the distance, let's say, right, we can memorize the distance. Maybe that will help it be faster. Distance function distance is, it will take this x1 comma x2 comma number of y. One is a number, y2 is a number to do Oh, it's finished. It took 5 minutes, but it finished. Ah, that's not the right answer. Your answer is too low if you're stuck. Okay. But let's do this memoization trick really quick. So let's do x2 comma y2 comma z2, join them together with a colon. Let's say if map key, then return map key, otherwise map key equals that, and then we can return map key instead. Here we can use the let's call this, I guess, calc. Will this speed it up? Not that much. It took 3 minutes to run. But we're creating too many strings. Let's ask ChatGPT again. Is there a bug in this? Because it did help us catch that bug earlier. Is there? 540 seemed like a really small number, but since we're only counting stuff, that's expected. Oh, it's saying what do you get if you multiply together the sizes of the three largest circuits. What we're multiplying is what we're currently multiplying is actually the lengths of the three largest groups of counts. So if there is like, if we get for example multiple fives, we won't multiply multiple. Okay, I think I figured out. So this is gonna be, instead of counts, it's gotta be I think let's do this. I'm gonna stop that and let's use the example instead. Stop it. Let's run it again. Wait a minute, what happened? What do I do? On 9:59. Mean junction. Okay. How did a null get in there? Oh, of course. At one point, this will not work. So we're trusting that our inputs are correct. We are told this only works if you do 10. So then we are told that. So let's remove that, and then 40 gets logged, but we don't have to group them. So let's do this. This grouping stuff is not actually needed. What we should be doing is all circuits, all not all circuits but circuits, and then two sorted, but we will compare them with their lengths. A dot length minus B dot length. Let's look at that. Console log counts. No. And then we need to reverse this. Now console no, const result is gonna be counts at 0 multiplied by counts at 1 multiplied by counts. Oh no, we can do this. Map x to x dot length to sorted based on, I guess we don't have to do the, if we do b minus a here, I think we don't have to do a reverse. Let's look at that. Five, 4, 2. So 2 and then counter 2 or exclamations all around. And then loop ban. Okay, this grouping was what's what gave us the incorrect answer earlier. Okay, I can say make this more perform. It took 4 minutes to finish earlier, so we should be optimizing, but I guess handing out that just optimizing this calc distance function didn't help us. The loops are what's killing us. The too many loops, and we know we're doing a lot of duplicate work because we're deleting those. We're generating a bunch of duplicate work and we're deleting it all in here. Well, hopefully this will be correct, and hopefully part 2 won't be harder, that much harder. Oh no, it should be a drop-in replacement. Okay, it re-implemented the whole thing. What's at the ASU? Did it say anything? Disjoint said disjoint union. Wow. Does it still use the 1000? Oh, it uses the thing. It uses the thing. Take the 10 shortest edges that can connect different components. This is actually good. Pre-compute or pairwise distances. Yeah, if we did this, it will be faster. I think this is one of those things that instead of caching the calculate distance, just pre-compute all of the distance between each vertex, because you can do that. And then sort the edges by distance ascending, and then for each one of those shortest ones, we keep our unions. We add them to our disjointed union, compute component sizes, disjointed union, find I, and then it sets, okay, gets the root, and then it counts up. Instead of pushing them, it counts the nodes. This would be good, but I don't think, maybe, I don't know what they're gonna ask us in part 2. They could ask us how many. Let's actually save this. So index.ts, parf.ts, save this. Instead of 10, instead of 10, let's take, okay, let's run it with the example. This is complaining because it's all, yeah, possibly undefined stuff. It's so let's do exclamations all around. I think it should be so. Let's run this over the example and see if it's correct. Index parf 50, it's not correct. What the heck? What the heck? Let's take a look at the size. 552, yeah, it's correct. It's incorrect. It has been more than 3 minutes. Why didn't this finish? Come on. It finished in 3 minutes earlier, I think. If we open up the open inputs/input.txt, how many we have? 1000. Oh no, well, not 1000. Yeah, we have 1000 pairs, and then we have to do 1 million distance checks and then store them in a map. But we're effectively accomplishing that by doing this, right? But we're doing this both, so this is more like, this is doing more like 2 million kind of, a map with 2 million values. We can add distances here. Let's distances. It's gonna be a record independent of which way we're going. That will help. We're doing way too many allocations with joining the strings and stuff, but can you do? Instead of joining to a string here, try creating a bunch of tiny little. Let's do that values, but instead of includes here, let's do find val where find I guess x comma y comma z where instead of doing the split and stuff here, we can do this and it will be the same thing. We can do the same trick here, kind of. We can say x comma y comma z, and then we can say fine, fine. There are a couple of joins happening here. Do we need them? We need them. We need them to access the object. We can't index an object by an array. Yep. What about here? We're doing the same thing again to check if it contains some key. Where is the key coming from? This can be x comma y comma z, which is a position, and then we can say circuits to find Oh, it took 11 minutes, but it did finish. Let's hope it's correct. Ah, fuck. I need that. Let's see if our modifications added any errors. They did. Let's look at this, the final. So if all circuits, and then filter where the find where includes them, where it includes them, where the circuit includes the current node we're looking at, and position is correct in this, right? Yes, it is. If we find it, it will not be null, or it will not be. I guess undefined. What does this return mean? I guess we can if it's true z. Okay, now it's 40. Okay, so that was the error. So we need to console log the result. We don't need to console log this. Let's add console.log connection. How much time is it taking to find? How much time is it taking it to find a single connection or say step? Maybe let's do this. Let's do this at the end of the call, or let's do this at the start of the call, because we can see how much time it takes till the next log. We can just visually. For our example, it will be no time, but for the input, it will be a lot of time. So input 1000, 1, 2, 3. That's way too slow. 1000 elements like that. How can we speed this up? And the issue is we can't even like quickly iterate on this because we can't even do that because the number we got, which was, yeah, that's not the right, your answer is too low. We got the incorrect. How do you get, what do you get if you multiply the size of the three largest circuits? Correct, that's what we're doing. I'm worried that this ended up being wrong. It's correct, it works for the example, it's correct. Maybe it's because there is some error in our memoized calc function here, calc distance function. Another thing I want to see is, are we getting cache hits, or let's say, or is this just adding overhead? Console.log cache hit, and then it keeps getting slower as we. Oh, so cache hits are happening, a lot of them. Okay, so I guess the map is working. The memoiz here is working. The memoization, the setup here is working. This is way too slow though. It's saying building the new array to index the map. It's gonna create noise. No, not noise, but it will make it. It's making it slower. It's saying it's making it slower. Whoa! It was actually making it slower. We thought we were making it fast, but we were making it slower. Stop doing for in over an object every step. For in over an object is slower than iterating over arrays. Okay. Okay, we can say compute the list and reuse. Nice. Okay, that's also another improvement. Okay, so we can, it doesn't change actually, and then we can say circuit. Oh, even outside of this we can put this outside. Circuit keys. Okay, hopefully it doesn't make it faster. How? Oh, off, not in, off. Okay, now that's a little bit faster, I think. So instead of doing a find, you should use a set instead. It takes it 1 minute to give me the incorrect answer. How can we even debug this? I don't even know what the heck. Let's see how performant this is. What, nothing is locked? So it's saying another thing we should do is have the record be but I don't know why the perf version is not running, is not even running. Main is never being called. This seems faster. What if it's already storing a circuit? No, if it's already using a fate, why shouldn't we? No match dot square root, no string building. I guess match dot square root is not really needed, right? I don't think it is. It's actually not needed. It said your answer is too low, but the answer we got from this is even lower than that. I think that we said the error we got is your answer is too low, and this is also too low. So let's look at the perf version. Let's say use the example. Yeah, it doesn't work for example. But I'm intrigued by the idea I suggested of saying using a set instead of list. So let's say if this is a set of this is a set instead. You can say, but this is actually what it said was stupid. We should be doing stuff like this. We should be doing stuff like this. We're creating an array and then we're creating a string. That's incredibly too much work. We're introducing too much work. That's the key. And then what we need to do is gonna be new set. And it will have new set and then circuits dot key add x y z, maybe. And then we can say dot get or dot is there not a get? There's no get. Let's oh no, remind me later. Did it just prompt me for an update in the middle of a stream? Let's see if we create a map. Let's say const map equals new map, right? And then map dot insert with 1,2 is hello. Oh no, I guess it's map dot add. What is it then? Const map equals new map, and then map dot add, map dot insert, map dot push, map dot set. Okay, if we set that and then do map dot get 1,2, we get undefined. Index map with array. Array to value map JS. That's not what I'm talking about. What? This worked for them. It worked for them. Map get. Why? It's because when there is a when you set a string key, so map get. Oh, you have to reuse the same object. So it's because they assigned it to a variable called key. Now we can't do that here. We can't do that. We can't. If we had the key, we would have used the key. We would have used the key. Oh no, I think we should be iterating over positions in here, right? And I guess to get the values we need to create a list, I guess, and we need to create a string. That's words that I think x2, no, y1 and y2, no, z1, and then move that up there, x2, y2, z2, and then we'll create we need to create the values here. Values dot have. Okay, I don't know if that will work though. New, okay, so set new set, and then it's one. So it has one element and that's an array. So if I say set has one, it will be false. Ugh. This is stupid. Come on. That's a stupid idea. Daily limbs are just a stupid idea, of course. Of course this won't work, because why, if it didn't work for a map, why would it work for a, why would it work for a, why would it work for this? We'll have to iterate over them and stuff, so let's undo this, everything, undo everything. That was a waste of time. But here, we can do this instead, I still like that. And then delete that and run. This will be colons. Yep, and then is there a bug in this? We want to know the three largest connections, I guess, no, groups after making 1000 connections. We're nearing, we're at 3 hours. We're at 3 hours, so messing around, having of code. 3 hours wasted. This. I don't know. I think maybe the grouping. Where should I don't know if I don't think the grouping logic is where the error is happening. Let's run it on the example just to be sure. Just to be sure. And 10 times it will be 40,000 times on the input will be something else. Maybe this logging is also introducing some time lag. No, that's incorrect. This is wrong. I'm measuring it between each one because we add all of them to the circuit group. This might be it. I was actually unsure about that part of the code. That might be it. That might be it. So it's here. It's telling us to create something like this instead. Optional, dedupe with a set or by string key. That's not optional. What the heck is it talking about? That's not optional. Well, this is true actually, I think. So values dot one, they get told about all of the values. Oh, I guess we should be contained pub. How can we deduplicate this? The union, we can't create a new set. To do that, we'll have to convert them all into strings. Here we need to do like something like this. Okay, if and then we would do if dedupe const dedupe fine. Y, Z. Even after the deduplication, it's let's look at the circuits. Circuits. One, two, three, four, five. These two form a connection. What happened? Why did we miss that? 431. It already had it, so it doesn't matter. But there are like, we're losing when we do dedupe. Deduping is correct. Our deduping is correct, but we gotta know if we gotta, instead of doing a while, we are going to say, we should be counting the valid connections and then looping until, like, how many iterations take us until we get to like 1000 connections made. True 1000 connections. But this ended up being 45. These two got merged. Okay, these two got merged. They duped and then merged. The unique is Arida from new map. I think this is already doing a deduplication, right? Is it not? Is it not? It was already being deduped. Frip was already being. These are already unique. Yeah, it's the same thing. It seems what we have, it seems identical with what we have now. Because we're making a connection between each other, between both of them. Both of them need to learn about each other's positions. But what we're missing here is we're not doing that for all of the values of this one. Does that for all the values as well. Let's say let's do that. Let's remove the number of let's reduce the number of logs we're doing. So let's remove let's log this unique thing. Unique. It's already doing to the dupe. Let's call it unique. This is saying 162 will now have these two elements, and then for both of them I guess for 162 and for 428. For all of them contained within the group 1, group 2. Shouldn't we be pushing the new connection in as well? Like this one? Shouldn't we be pushing this into the list? Like unique, no, let's say union, now push. Does that make sense? Does what I'm thinking make sense? I think it does. It's like we're not adding those. I don't think we are. Let's say mean junction. In that case, this is gonna be something like this. Still 45, but the logs are heavily reduced. Oh, we stopped the logging unique. We should be still be logging unique, but let's try adding the mean junction. But they were already in there, so yeah, it doesn't really matter. Yeah, it doesn't really matter. Let's do Q1 and key 2. but here we're building it out as we go. 162. There's supposed to be 1 with 4 finally at the end console door circuits. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Wait a minute. Oh, it's there. It's there. 984 is there. 862 is there. In this case, we're not seeing any with only a single connection. It's like there are only 4 of those, but in here, 7 circuits with each contain a single junction. It's like this. At this point, there are only 4. 1. Maybe we are making one more connection that I should be doing. We go for the circuit, and then we let's look at contained in pause and contained in. Is it removing the maths dot square root? That's causing problems? No, it's not. It's like if it's a bigger number before the square root, it will be a bigger number after the square root. Yeah, I don't know. I think we're not gonna even solve part one today. And I'm gonna compare this with source index like this. Okay. So, oh, no, not gonna be looking that there. Speed looking that there. This is the correct one. This is yep, this is the correct one. And then this is the incorrect one. So let's look at the largest one, for example. What is it missing? It's missing 346. What did 346 create? It didn't even connect. It didn't even get connected. So what we should be seeing is, let's see, let's do something like this. Console log. Are the connections being made different? Connection. No, not connection, but mid junction, min junction, dot join. How did they miss that? Both of them are using, yeah, that. one misses that. Maybe because something like this. Oh, not there. I meant to do it there. It's because of this. In the following. That's the one that works. Yes. If we keep connecting the first 1000 shortest connections. It does give us the correct arba, no, like it's the answer, but it's not really working. I tried implementing this DSU stuff again. What is this? Disjoint set union. I think it's time for me to give up. Maybe I don't know. Yeah, it's done. It's Denzel Washington. Let's update this. That button. The algo is incorrect. We ended up at this state, which is wrong, but we know the input is correct. What prim like? Where are we going with this? Kruskal? I've never heard of these words before. So it's saying your initial code had a bug, so I implemented the same bug, but not example. It's whoa, what is it doing? That's super slow. Let's just reread the description. Among all representative, find the shortest connect entire components by merging their nodes. Repeat this process 1000 not gravis. Okay, it might be correct. I guess it has to be a triple loop. It has to be 4 const a K1 in reps for K2 in reps cut distance. How did this end up being so much slower than the previous one? It's basically doing the same thing. My previous one had like conditions here that bail out early, but uh, but Larry, I think we're not gonna do it. Let's see who has solved this. Let's go to leaderboards, view. Yeah, Biniam and David have already solved it. Yeah, goodbye everyone. I think I'm not gonna solve it today.